How to get better results using agents. Hello everybody and welcome again to another video about agents. In the past few weeks I didn't cover many videos about agents. I focused mainly on other stuff such as Qualitative, which is amazing. But today I'm going to share with you a research that I stumbled upon, which is about agents. I didn't actually use the repository yet. I didn't test it, but I wanted to share with you this research because I think it has many great takeaways and learnings that can be implemented when building agentic systems. So I will also drop the link to the research in the comment section, in the video description. Now let's get going. So the research paper is called Agent E, from Autonomous Web Navigation to Foundational Design Principles in Agentic Systems. And let's just get going. So basically what they say at the beginning is they just cover how agentic frameworks are gaining popularity. And today a typical web agent usually has limited abilities. We need to put many constraints and guardrails in order for the agentic framework to yield the results that we would like. So as much as I believe in projects such as AutoGen and Crew AI, still when I want to build an agentic like a production ready project using agents, I still cannot do so. So this research tries to cover how can we improve the agentic frameworks. And yeah, let's just get going. So basically a typical web agent at its most basic has two capabilities: the capability to sense the web page and the capability to act on the web page. And bear in mind that they are focusing on agents that are helping with browser automation. So sensing basically means sensing the state of the web page. For a web agent, typically involves encoding the document of the page and using accessibility tree of the page and using screenshots of the page. So these are basically the ways that we can sense the web page, or the agent can sense the web page, via screenshots or via just analyzing the code. And we have the acting portion, which the action space can be comprised of simple actions such as navigating to URLs, clicking on elements, and entering text in a field, or composite actions comprising of several simple actions. So an example would be filling a form, for example. So basically what they say, there are kind of two types of agents: the sensing and the action. So developing a robust web agent that can autonomously perform tasks on the browser presents multiple challenges. We know that, but they define this very nicely. So firstly, HTML document can be noisy and expensive, so often exceeds NLM context. So when the HTML is very long and there are a lot of text, so the context window is just too short for digesting the whole HTML. The second thing is websites are primarily designed for human visual consumption, wherein information is organized to prevent information overload for a user. Thus, websites utilize established human-computer interaction patterns that may not be optimal for agent interaction. Complex widgets such as data selectors are easy for humans to operate, but pose difficulties for agents. And thirdly, while humans can naturally execute complex web tasks, agents require detailed multi-step planning to execute such tasks. Okay, so this is clear and pretty interesting. So what in this portion, they discuss the fact that so far a few benchmarks were built in order to assess the agentic framework or the agent's ability to create browser automation, but it was mostly focused on reporting success rates. And what they are proposing are a few more parameters in order to assess the web automation, the agentic web automation. So first of all, task completion times, the duration required for a system to complete a task, which impacts overall efficiency and productivity. The cost involved in completing a task, and the error awareness, which is very interesting and very important. The capability of the system to recognize and report its own errors, which ensures reliability and ability to provide a seamless user experience by highlighting recommended fallback options. And again, this is very important because, for example, when I build an automation, even with an RPA tool, Power Automate, I didn't necessarily think about the importance of error awareness. Yes, I create an error log, but I didn't think about the ability of analyzing different errors and edge cases. So this is why I like this research, because there are so many takeaways, at least for me, from the way that they wrote this and their analysis. So let's move on. Basically, they say that their agent can run in two modes, autonomous mode and human in the loop mode, but they are covering in this paper mostly the autonomous functionality, since this is how the benchmark was built, the Web Voyager build benchmark, which if you didn't read about it, I highly recommend that you check out this benchmark. Now, this is a gist of the things, the contributions. I'm going to go over them, and then I'm going to read like a more detailed learnings and how they structure this, how they design the agentic framework. But if you're short on time, this will give you the gist. So first of all, what they say: we introduce a novel hierarchical architecture for web agents that enables the execution of more complex tasks through a clear separation of roles and responsibilities between a planner agent and a browser navigation agent. We illustrate the utility of hierarchical architecture for capabilities such as task verification, backtracking, and error recovery, with examples where these capabilities are invoked. We propose a flexible DOM or DOM distillation approach, whereby given a task, the browser navigation agent can choose the most suitable DOM representation from 3 different implementations, and they demonstrate effectiveness in the examples. We highlight the benefits of change observation. Basically, after each execution of each action, the outcome or change of state is monitored and used to provide a verbal feedback to the browser navigation agent. And this guides the agent towards better awareness of the current state and more accurate performance. We will cover this more in depth later, but basically after each move, they kind of reanalyze what is being shown on the screen, and based on this they move forward. We report detailed end-to-end evaluations of Agent E. Basically they achieved a 20% improvement over the top player at the moment, and they say that they now offer more criteria, more parameters to analyze the agent, so beyond success rates, this is what we discussed before. Okay, now, first of all, they built this agent with Autogen. If you haven't seen Autogen, check out my other videos about Autogen. It's an agentic framework built by the Microsoft team. This is basically how it looks like. Let's move on because it's not crucial. I mean, it is crucial, but we are short on time, so I just highlighted all the stuff that I think is very crucial. So as we said, we have 2 key differences between Agent E and previous web implementation. And what they have here is they have the sensing agent, which supports multiple DOM synthesis. And this means basically, so if the task is to summarize information on a page, the agent simply gets the text only content, only the content, like in text form. So it realizes it's only required to give a summary, so it only pulls out the text in the page. If the task is to identify and execute a search on the page, it looks for input fields. So basically, based on the task, it analyzes which parts of the HTML it needs to extract. And it looks like this. So basically, a new task is given. So it uses the planner agent. He basically sees what is the next step of the plan, how to address this. It forwards the instructions to the browser navigation agent. He acts, and also afterwards he immediately senses what happens to the web page, if a pop-up appears or not. It does denoising, so it removes all irrelevant context, and then it checks if the step was complete or not. If it was complete, it moves forward to analyze if the task was complete. If the task was complete, it sends a response. If the task wasn't complete, it replans and goes back here. And if the step wasn't complete, it just identifies the next browser interaction that it needs to do. Here's a table of basically all the ways, let me see. So all the skills registered to a browser navigation agent for acting and sensing the web page. I think this is very interesting and important, but it will be a bit too long if we cover all of this. So if you're interested in building an agentic framework, definitely read this portion. Okay, so all action skills are designed to not only execute an action, but also report on any change in state as an outcome of the action, a concept we call change observation. This is conceptually similar to a reflection paradigm, which uses verbal reinforcement to help agents learn from prior failings. However, a key difference is that change observation is not directly associated or limited to a prior failure. The observation returned can be any type of outcome of the action. For example, a click action may return a response clicked the element with MMID 25. As a consequence, a pop-up has appeared with the following elements. Such verbal responses nudges the agent towards the correct next step. Change observation capability is implemented by observing changes in selected attributes. So this is a great example. Okay, this should be big enough. So the user asks, find the price of Canva team subscription and minimum number of users required for it. The planner, using AutoGen, plans, navigate to the Canva website, locate and navigate to the pricing or subscription page, identify and extract the price of the Canva team subscription, identify and extract the minimum number of users required for a team subscription. So it navigates to the browser agent. Then you are now on the Canva homepage. Currently, this is the URL. There it asks, the planner asks, is there a link or section labeled pricing or plans? The browser navigation agent says, yes, there is a section on the page labeled plans and pricing. Would you like to navigate to this section? Then it says, navigate to that section. Then it says, I navigated to the plans and pricing section on the Canva website. I clicked on the plans and pricing buttons. This opened a drop-down menu. From there, I clicked on the compare pricing link, which redirected to the detailed pricing page. Then the planner asks, is there information available about the Canva team subscription, specifically the price and the minimum number of users required? And then it answers, the Canva team subscription is priced at 90 euros per year per person with a minimum blah, blah, blah. And then since the task was completed, it says the price of the planning agent says the price of the Canva team subscription is 90 EU per year, blah, 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 moving on. So now they cover the evaluation, how they were able to achieve, how they compared their performance to the benchmarks, and this is like the measures, what they achieved. Okay, so they cover first of all what was the task success rate, then the self-aware versus oblivious failure rates. So this is very important. Again, it refers to what we discussed about before, understanding where they were wrong, which is very important. Task completion times and total number of LLM calls, which basically translates to cost. This is the bottom line in terms of performance, which as you can see here in different websites, Agent E got way better results. Moving on. Now they discuss different modes, not crucial in my opinion. Okay, now a few takeaways. So first of all, they say that the hierarchical architecture allows easily detecting and recovering from errors. The planner agent is prompt to perform verification by asking questions or asking confirmation as part of the plan whenever necessary. And this is an example. I won't cover this because the video is getting a bit too long. Change of the observation helps grounding. So this is very important. Again, we discussed this, but let's make sure that this point is completely clear. Change observation is a concept we introduced in which after each execution, we also observe for changes in the state and return a linguistic feedback to the LLM. where they had an example. Wait a sec. They had an example over here, but let me see. Okay, another common example is when browser or navigation agent attempts to set a source airport in a flight booking website, and a list of possible airports open up as a drop-down. The interaction is not yet complete, but the browser navigation agent may assume it is. And then in both cases, this click skills will return a feedback to the LLM that as a consequence of the click, a menu has appeared where you may need to make further selection. So basically, the change observation just allows us to break down small chunks of I wouldn't say even tasks, more like steps that we didn't even expect. So let's say we want to fill out a form. So we start, let's say we start filling out a form, and then we gave the input, and suddenly another, let's say we fill out a form. How did you hear about us? So usually you have, when you fill out a form, when the question is how did you hear about us, you have Google, Facebook, and other. And when you click other, sometimes you get another input field which suddenly appears, which you didn't initially know about. And in this case, the change in observation would spot this. Basically, I'm just re-saying these examples as they already shared. Hope it didn't confuse you. Yeah, moving on. This is the most important portion of the research, in my opinion. So discussion. First of all, a well-crafted set of primitive skills can enable powerful use cases. A well-crafted ensemble of foundational skills can serve as a building block to support more complex functionalities. LLMs can effectively combine these skills to unlock a broad range of use cases. So basically, they suggest breaking down the agent to many simple and primitive skills. Consider hierarchical architecture for complex tasks. So basically, I also discussed this in other videos of mine, and we already said this in this video. Building hierarchy and using nested chats in Autogen allows you to create nested chats is very powerful. But again, it is not suitable for all tasks. You need to think through if you want to create nested chats and basically hierarchy in different tasks. You need different types of hierarchy. This was interesting. So perform payload denoising when relevant. So mitigating noise in the payload is critical in creating reliable, cost and time efficient agents. Noise can be in the form of unnecessary or irrelevant information, which could lead to incorrect or suboptimal performance. So basically what they say, filter out whatever you can before sending stuff to the LLM. So for example, let's say I'm scraping different websites, so try to filter out, let's say I only want the links, so obviously filter out the links prior to sending them to the LLM, instead of sending the whole HTML to the LLM and then asking it to extract the links. So basically the notion that you should denoise the data and send the LLM only stuff that is necessary. Provide linguistic feedback of actions. We cover this, I think I repeated this for like 5 times during the conversation, this video, so I will skip this. Support human in the loop when necessary. This is also pretty straightforward. But yeah, this is agentic frameworks are very promising, but at the moment you can't rely on them except for research maybe, so definitely need a human in the loop. Analyze, reflect, and aggregate past experiences routinely for self-improvement. This is also pretty straightforward. Introduce internal and external guardrails into agentic systems. So to ensure safe and effective operation of an agentic framework, it's important to introduce various guardrails into the operation. These guardrails can be in the form of rules, guidelines, or constitution that system must adhere to. Some of the guardrails may be external to the system. For example, task appropriateness guardrails may filter out inappropriate tasks even before agentic system is invoked. In addition, there could be a guardrail intrinsic to the system, such as guardrails against prompt injection attacks and operational guardrails that limits how the agent performs different tasks. In the context of the Agent E, the operational guardrails include domain boundaries within which Agent E should operate, task-specific boundaries, and user-configured boundaries. So this is very interesting, actually. So when you build an agentic framework, think about the guardrails, and these can be broken down into task-specific boundaries, user-configured boundaries, business boundaries, inappropriateness boundaries. So how to pronounce? Anyway, the concept of baking in guardrails into the agentic system is very important, mainly in the production level or when the risk is pretty high. At the moment, for me, I don't use this very often. Maybe I should. And the choice between generic agent and task-specific agent. So generic agent systems by definition can perform a wide range of tasks. However, in many practical implementations, a more focused set of capability may be desirable. For example, Agent E is a generic web agent that can perform a wide range of tasks on the internet, but not necessarily optimized for any specific task. It would be possible to optimize Agent E for a specific type of task, for example, form filling or specific websites, for example, only Amazon, to achieve significantly higher performance, depending on the use case. So yeah, this is also very interesting, especially when you can give them different sources of knowledge, and you can give them different models, and you can give them different system messages. You can basically create specialized agents which can be very powerful. Reminds me of Adam Smith's theory of Adam Smith was a famous economist, and he said that basically economy moves forward when people have specialties. This is just a paraphrasing and the gist of one of his ideas. I highly recommend that you check out his stuff, although a bit boring to consume, but very important concepts. Anyway, specialization is very important. Very hard to pronounce these words today for me, especially. I don't know why, maybe I'm tired. Anyway, so you get the idea. Specialty, very important. It can be baked into the system, and whenever you want to build something in production ready, you should definitely consider using specific models and providing a specific knowledge base and providing a specific system prompt. Obviously, memory, and there are a lot of moving parts that you can bake into the agent in order to yield better results. I guess that's it for today, guys. I hope you enjoyed this video in which I covered this important research. I didn't even cover the actual performance. I mean, didn't even test Agent E, but I think the principles are more important, and I wanted to share them with you. I hope this wasn't too long / boring, and hope you enjoyed it and learned a bit about how we can build better agents. If you enjoyed this video, please like and subscribe. Obviously, if you have any suggestions, ideas for optimization, leave them in the comment section below. And until next time, keep on automating.